everyone, we're going to graph the polar equation. It's going to be a parabola. We have r equals 2 divided by 1 minus cosine of theta. Before we graph it, we have to test for symmetry to see if it's symmetric to the polar axis or to the line theta equals pi divided by 2 or to the origin. Most likely when you have cosine, it's going to be symmetric to the polar axis. So let's go ahead and do that. For this test, we're going to replace our theta with negative theta. And that's going to be r equals 2 divided by 1 minus cosine of negative theta. Now, since cosine is an even function, this gives us 2 divided by 1 minus cosine of theta, which is an equivalent equation to what we have. So this test passes. All right, let's check which is what we suspected with cosine. It shouldn't pass for this one. Let's look and see. For this test, we replace theta with pi minus theta, So we have r equals 2 divided by 1 minus cosine of pi minus theta. Using our difference formulas for cosine, we can expand this as equals 2 divided by 1 minus cosine. Let's put this in parentheses of pi times cosine of theta plus sine of pi times sine of theta. All right. Sine of pi is 0. Cosine of pi is negative 1. So you have two negatives here, and we're going to get this equals 2 divided by 1 plus cosine of theta. That's just going to be negative 1. Since these do not equal, these two equations are not equivalent, this test fails, which is what we suspected. And also for this one, the pole, you just substitute in r for negative r, and clearly it fails this test because they're not equivalent equations. Since we have it passing with symmetric, being symmetric with respect to the polar axis, we're going to assign our values for our angle between 0 and pi. And then we're going to copy the other half of the graph based off this. All right, so let's evaluate from 0 to pi. At 0, it's undefined, so can't do anything with this. At pi divided by 6, we're going to have 2 divided by 1 minus square root of 3 divided by 2. This is approximately 14.9. At pi divided by 3, we get 4. At pi divided by 2, we get 2. At 2 pi divided by 3, we have 4/3. And at 5 pi divided by 6, we have 2 divided by 1 plus square root of 3 divided by 2, which is approximately 1.1. And then at pi, we're going to get 1. So this is the upper half of our quadrant, and let's plot some points and see what we get. So let's start with pi divided by 6, and at pi divided by 6, it's right here. So let's look and see what we have. Pi divided by 6, we're at 14.9. So if I go by 2's, 2, 4, 6, 8, 10, 12, 14. So I'll put the point right there. At pi divided by 3, we're at 4. So this is 2, 4. So it's coming in this way. At pi divided by 2, it's at 2. Because remember, I'm going by 2's here. At 2 pi divided by 3, we're at 1 1/3. So it's coming in closer here. At 5 pi divided by 6, we're at 1.1, so it's really close to 0, and or kind of close to the origin here, the pole. And at pi, we're at 1. So let's put it here. So let's just make it kind of like that. All right, so we got the first half of the graph, and now let's look at the second half. So basically, we're just looking at, for example, 11 pi over, 11 pi over 6 is going to be about 14.9 of 15, so put it about there. At 5 pi divided by 3, you look at this one and go out 4. 1, 2, 3, 4. So we're coming in this way. At pi divided by 2, we had 2. So at 3 pi divided by 2, we're at 2, which we're going by 2. So we're back to here. All right. And then you can kind of just connect it here. You can fill in more of these values if you want. But this graph is symmetric to this pole here, the polar axis. Thank you. Let's go ahead and graph the whole thing in one color. There is your parabola. Thank you. Have a nice day. Bye-bye.